Then let's talk about the immunity characterization, because as I said, electromagnetic compatibility deals with emission and immunity. And now we have to figure out how we can characterize how robust are our ICs against interferences, radio frequency interferences, for example. So in this case, we also have a standardized measurement setup, and the standard is the IEC 62132 standard. It's also more than 20 years old. Measurement of the electromagnetic immunity from 150 kilohertz up to 1 gigahertz. So again, we have the problem with the higher frequency range. In the same way as the emission standard, it's also defined in several parts. -1 gives some generals and definitions. So how does the noise signal look like? What frequency range should I measure? How long should I remain at each frequency position when I'm interfering? Should I use a continuous wave signal, an amplitude modulated signal, a pulse width modulated signal, or a pulse signal? So everything is defined here. And then we have measurement techniques. And taking a look at that, you will see you are already familiar with quite a lot of measurement techniques. Because we already talked about the DEM cell and the wideband GTEM cell. We can also use it in the other way around to inject some RF interferences. We'll show it later. Generate some electric fields and magnetic field inside of the DEM cell and try to interfere the operation of our IC. A new thing is the bulk current injection, or BCI measurement technique. It also comes from the Society of Automotive Engineers, and it was originally defined to characterize the conducted immunity. Also a new thing is the direct power injection method, DPI. It comes from the VDE, Verein Deutscher Elektrotechniker. We are already familiar with the workbench Faraday cage. Okay. Yeah, what about generating a noise signal? And what about forcing this noise signal from outside into this Faraday cage and drive the noise signal across the signal return plane by clamping the noise signal right and left to the ground plane of our printed circuit board and driving a current through the printed circuit board. That's the basic idea behind this workbench Faraday cage immunity test. Then again, we have the IC stripline method, okay, already discussed, and we have the surface scan method, but in this case for the radiated immunity test. Okay, there's a special reason why two measurement techniques are highlighted in red here, and the reason is these are the two measurement techniques that, at least from our perspective from the Institute, are the most important ones, and I think these are the ones that are used, I think, worldwide to characterize the immunity of ICs. The DEM cell and the direct power injection method.